In this video, I'm going to talk how to solve combined circuits. What are combined circuits? Combined circuits are circuits that contain both series and parallel branches. One node is the place where one path splits up, or the place where three branches come together. To solve problems related to combined circuits, we are using Ohm's law and rules for finding voltage, current, and resistance. Ohm's law states that the potential difference V to current I is constant. There are three formulas we are using to solve combined circuits. In addition to Ohm's law, we also need to use the rules for finding current, voltage, and resistance in series and parallel circuits. To remember Ohm's law, you might use this triangle here, put voltage at the top, and if voltage is required and current and resistance is provided, then you multiply I times R. If voltage and current is provided, then resistance is V divided by I, and current is V divided by R. Let's take a couple of examples. But before, we need to recall the laws for finding these three variables in series and parallel circuits. For a series circuit, formulas, rules for finding total current, total voltage, and resistance are provided in this box here. For parallel circuits, total current, total voltage, and total resistance is provided in this box on the right. Now, example 1, we have a combined circuit here. Voltage is provided 20 volts, and we have three resistors, 1, 2, 3. The values for resistance is given, 20, 30, and 10. Now, if you know how to solve this, you try now, and if your answers are the same with those provided in this box, you don't need to watch the video. Pause the video and try now, and find out if you need to watch it or not. To solve these combined circuits, we start with simplifying this circuit by reducing these two resistors in one, and the circuit becomes a series one. Let's find the resistance for these two resistors. 1 over R2 R3 is equal to 1 over 30 plus 1 over 10. You add these two fractions, get 4 over 30. Then to find the resistance for these two, R2 and 3, you cross multiply, divide by 4, and you get the resistance 7.5 ohms for this part of the circuit. Now, total resistance is 20, which is this value here, plus 7.5, and the value is 27.5 ohms. Now let's find the total current. Total current is total voltage divided by total resistance, applying Ohm's law. And total voltage is 20 divided by total resistance, we just found 27.5, and the current in the circuit is 0.73 amperes. Now, voltage for V1 for this part here is I times resistance 1, 0.73 amperes, because the current in this part here is the same with the current coming from the source. It's the same flow of electrons. So 0.73 amperes times 20, which is the resistance at this point, 14.6 volts. Now, the voltage for these two branches here is equal because they are parallel. Now, voltage in V2 equal to voltage at V3 equal to 20, which is the total one, minus the drop at this point here, which is 14.6, we get 5.4 volts. So each branch here has a voltage of 5.4 volts. Now current for this part here, current I1 is 0.73. As I mentioned, is the same with the current of the source. I2 is V2 over R2. V2 is 5.4 divided by 30, which is the resistance. You get 0.18 amperes. I3 is V3 over R3. 5.4 divided by 10, it's 0.54. If you add these two values together, you will get the total current 0.73 amperes. Then you fill in the table. Example 2. We have a more complicated circuit here because we have 4 resistors. We have R1, 5 ohms, R2, R3, and R4. Total voltage here at source is 24. Now let's fill out the table for the voltage, current, and resistance. Resistance for this part here, we reduce these two branches in one, is 1 over R2, R3, to get 1 over 4 plus 1 over 6 equal 5 over 12. And then you find R2, R3, which is 12 divided by 5, 2.4 ohms. Now total resistance now is 5, which is this part here, plus 2.4 for these two branches, plus 3 here, and the total is 10.4 ohms. Total current is total voltage divided by total resistance, applying the Ohm's law. Total voltage is given, 24, divided by total resistance we just found, 10.4, and the total current is 22.3 amperes. Now voltage at this point here, at the first resistor, is 2.3, which is the current, times 5, and you get 11.5 volts. Now let's leave this for a while and let's find the voltage for this part here. At the fourth place here, V4 is 2.3, which is the current coming back to the source, 2.3 times 3 is 6.9 volts. Now we know the voltage at this point, which is 11.5. We know the voltage at this point, which is 6.9, and we know the total voltage. Now 24, which is the total, minus 11.5, which is the drop at V1, minus the drop at the fourth resistor, which is 6.9, and then the voltage for these two branches, for each of them, is 5.6 volts. Do not divide the voltage here. Voltage is equal because we have a parallel part here. Now, what is the current I1? I1 is 2.3 amperes because it's the same with the source. I2, it's V2 divided by R2, 5.6 divided by 4, which is the resistance for this, 1.4. I3, 5.6 divided by 6, 0.9. If you add together these two branches, you'll get the total current 2.3 amperes. Now you can fill in the table. Thank you for watching the video.